Thank you for joining us tonight for our RiverWatch Winter Speaker Series. For those of you who are not familiar with the Illinois RiverWatch Network, RiverWatch is a community science organization that trains volunteers to monitor water quality in their own communities. The mission of RiverWatch is to safeguard the future of Illinois rivers and streams through stewardship, education, and sound science. Before we get started, I ask that you keep your microphone muted during the presentation to limit the distractions. We will have a Q&A session after the presentation, so if you have a question along the way, you can either put it in the chat box and it'll be answered at the end, or you can save your question and ask it aloud. Now I would like to welcome Manisha Pant. Manisha has been the Macroinvertebrates coordinator with the Illinois River Biological Station's Long-Term Resource Monitoring Program since 2023. She earned her BS and her MS degrees from Eastern Illinois University, where her research focused on the effects of in-stream restoration on fishes and macroinvertebrates in a small stream. She then joined the Virginia Institute of Marine Science, where she served as a lab manager and research specialist responsible for organizing, collecting, processing, and analyzing data from the marine and estuarine benthic ecosystems along the East Coast and the Gulf of Mexico. And with that, I would like to welcome Manisha Pant.
Thank you, Hannah. I'm going to share my screen here. All right. Thank you, Hannah. Thank you, everyone, for joining in today. I'm Manisha Pant. I'm with Illinois River Biological Station. Many of you here already know what is benthic macroinvertebrate, but I am going to define it anyway. So these are organisms that inhabit in bottom of an aquatic body, which are large enough to see with our naked eyes, and they lack backbone. These aquatic macroinvertebrates live in water for at least part of their life cycle. So why are these important? Why do we study them? So they are important food source for fish, birds, amphibians, and reptiles. They play a vital role in nutrient cycling as they are primary processor of organic materials. They are biological indicator, meaning they are sensitive to pollution. So they will respond to many kind of pollution. Their presence and absence provides us clues with water health. And also they can reflect past or cumulative pollutants in the water. So how do we know what macroinvertebrate, how do they tolerate to pollution? So we have three groups of macroinvertebrates. So group one, which consists of macroinvertebrates like caddisfly larvae, mayfly nymph, these need good water quality. So they are generally pollution intolerant. And then we have group two macroinvertebrates like dragonfly nymph, amphipods, and these can live in wide range of water quality condition. And then we have group three macroinvertebrates like leeches, midges, they can tolerate pollution and survive in poor water quality. So how do we use them to know the health of the system? So for example, this is our sample. And there are many matrices we use to score our stream or river. So one of the example is biotic index. So how do we use this? So for example, this is our sample. So you score each bug in this sample, and then you add the score to get one index for the entire sample. So if you end up getting higher index number, that meaning you have polluted system. And if you end up getting lower index, that means you have a good system there. So this is just one example. There is like other calculation involved here. I'm not going to go in detail. I'm just trying to show you example how we use macroinvertebrate to score the river health. And another example is percentage EPT taxa, which is very widely used. So EPT meaning Ephemeroptera, Plecoptera, and Trichoptera. So these are mayfly, stonefly, and caddisfly. So these taxa are considered pollution sensitive. So if your sample has higher proportion of EPT taxa, this suggests that the system is less polluted. But if you have lower proportion of these taxa, that meaning your system is more polluted. So there are other matrices also. I just wanted to point out few of these matrices that we use to score the river condition. So here I have a flow chart of biomonitoring. So how does this work? So the sample is collected using both qualitative and quantitative techniques, and then samples are collected and preserved in preservative, and later in the lab, we sort them and identify them to lowest taxonomic label if possible. And then once all the identification is done, data is analyzed, like determination of density, frequency, and such. And then later we develop IBI score to know the condition of that river or stream. So with that, who are we? So what do we do? So I work with Illinois River Biological Station, which is one of the 6 stations of Upper Mississippi River programs long-term resource monitoring element. So we have 6 different reaches. So here you are seeing Pool 4, Pool 8, Pool 13, Pool 26, and Open River Reach in Mississippi River, and Lagrange Pool in Illinois River. So there are different kind of long-term surveys going on all these reaches, like fish survey, vegetation survey, water quality survey. But we were missing macroinvertebrate survey, which was done in the past, but it got terminated. So in 2023, the program is reinstated for all of these reaches. So I'm the macroinvertebrate coordinator for all these reaches. So before I jump into 2023, I wanted to tell you about what was done in the past. So the macroinvertebrate sampling in all the pools, 4, 8, 13, 26, and open river reach of Mississippi River and Lagrange Pool of the Illinois River was initiated in year 1992. And at that time, they had some targeted taxa like mayfly, fingernail clam, exotic Asiatic clam for monitoring. So they were basically just counting these targeted taxa. And later in 1993, they added chironomids, and they added zebra mussel in 1995 in their monitoring program. And they started recording presence and absence of different taxa like odonates, oligochaetes, gastropods, and such since 1998. And they were doing all this monitoring for all the reaches throughout the Mississippi River and Illinois River. So in 2001, they had to drop Open River Reach because they were seeing low densities of mayflies and fingernail clams, which was due to unfavorable habitat for these taxa in Open Reach. And then unfortunately, in 2005, the macroinvertebrate sampling was terminated due to budget constraint. But in 2023, the program is reinstated because we got the funding. So this is just the overview of what we did in 2023 and what I'll be talking to you about. So the table here you are seeing is the number of samples, number of sampling sites across the pools in the habitats, which are generated by stratified random sampling design. So all the habitats are represented. The acronyms you are seeing here, like BW represents backwater, IMP represents impounded reaches, SC represents side channel, and MC represents main channel. I mentioned earlier that they dropped the open river in 2001 because they were seeing low density of targeted taxa. And if you see here, we do not have any sampling sites for open river for 2023 as well. But, it has been 20 years since we haven't sampled, so we thought things have changed, so we decided to revisit Open River. So we actually sampled Open River. So we revisited 16 fixed sites from historic sites and 112 random sites. And for these sites, we were using Ponar graph to sample macroinvertebrates, but this time around, we introduced new passive gear, which is Hester Dandy and rockbacks in the main channel. But I'll be talking about this later again. I just wanted to let you guys know that we have 25 of those sites for each pool. So what new we did for, sorry. So what new we did in this program? So we added a data apps, which made our life really easier. We did not have to get paper and pencil while we were out in the field. So this data app has already preloaded primary sites, alternative sites, and then already preloaded barcode for our jars, sample jars, and then all these drop down bottom so we can select habitat information. So this was new addition to our this 2023 program. This wasn't done in the historic sampling time. So this is the overview for you to see the difference between historic sampling and recent sampling. So we are still using Ponar sampling, which is the active gear, so that we can compare our current data with our historic data. So we are still using our active gear. And this time around, we added data app, which I just explained you. And then we introduce passive gear to see what's going in the main channel. We were missing the macroinvertebrates from the main channel in all our LTRM reaches. So we introduced passive gear, which I'll be talking later in the slide. And then we are using mayfly to detect the contaminant labels in the river. So this is new addition as well. Then we will be developing IBI score later to look at the river health. And then this time around, we are trying to identify all our macroinvertebrates to lowest taxonomic label. In past, they were only identified up to order or family label. So to me, I feel like identifying them to lowest taxonomic label is really important. For example, like if you look at this order here, Trichoptera, which is caddisfly. So if you just identify them to order, the tolerance value is 3. And if you go a little further, let's say, for example, this family Hydropsychidae here, the tolerance value is 6. But within that family Hydropsychidae, if you look at these two genus, Ceratopsyche and Pneumatocyche, the tolerance value for these two changes. One has 6, which is like more tolerant to pollution, and the other one has 2.9. So the main idea is within the same measure group, different species have different tolerance values. So to me, I feel like always trying to identifying these organisms to lowest label is important. And some of you are, like there are papers out there, they argue, that costs a lot of money, manpower, it's very tedious work, and I completely understand that. But it also differs with project to project, what is the goal of the project. So the goal of our LTRM program is to have most of these all of them identified to lowest taxonomic labels. So we know the list of species in Mississippi River and Illinois River. And also we might encounter some invasive species or any rare taxa. So if we just stop in order label, we might be missing out on these things. So with our new re-implementation, we will be identifying all these species to lowest taxonomic level. That is the plan for now. So let's start with the first sampling method, which is the ponar grab. So the picture here on the right you see is ponar grab here. This is a very heavy equipment. So here I have a timeline when we usually sample. So we usually sample once a year in spring. And when I say lower station, I am talking about Lagrange, Pool 26, and Open River. And when I'm talking about upper station, I'm talking about Pool 4, Pool 8, and Pool 5. So usually at the lower station, we start our sampling around April 15. And then in upper station, they start their sampling around May 1st. So just to give you an idea of how Ponar works, I have a small video here. So once we go to our sampling site, we drop this Ponar in our sampling site. This is really heavy, as I mentioned earlier. So with the help of the winch, we drop it. So once it hits the bottom, it bites the sediment and then it closes, and we bring this up on the boat where we have a tray with a mesh on it, so the sediment doesn't wash out. So we take out everything from the ponar. So Anthony here is rinsing the ponar. So just to sum up, so what we do in the field during ponar sampling is we get our sample grab, bring everything on the tray that has a sieve. So we try to get rid of all the sediment to make our life easier in the labs where we will be sorting for bugs. So once we are satisfied with the amount of sediment remaining in the sample, we transfer everything to our sample jar and we make sure that nothing is left behind. So we scan through the sieve, the tray, and then make sure no taxa is left behind. And if there is anything, we pick them up with the help of forceps. And the sample in the jar is preserved in formalin, and the pre-label barcodes are attached to the sample jar. So while we are doing this, one of our team member will be filling all the field information in the data app that I talked earlier. So all the site information, habitat information, even the number of mayfly we found on each ponar, that will be recorded in the data app. So that was really easy to use the data app. So this is done for all the 6 sites. So we will be getting like hundreds of samples. So that will be sent to our field station back to Illinois River Biological Station for further processing. So the picture on the left, my wonderful team members, Rachel and Abby, helping me transfer all the samples from formalin to ethanol. And then we try to re-sample more here, just to trying to get rid of more sediments here to make our life easier again. So the picture on the right here, Rachel is really happy to sort some bugs from the sample. So, and we do this for all samples from all the field stations. So let's go to the another sampling method, which is a new addition to this macroinvertebrate component. As I mentioned earlier, these macroinvertebrates are bioindicators and they can reflect past or cumulative pollutants in the water. So we wanted to know the contaminants in the river. So we chose borrowing mayfly Hexazenia species for this. So why did we choose Hexazenia species? So these mayflies, They inhabit and ingest fine-grained sediments and detritus, which may be enriched with metals and persistent organic compound. And they can externally absorb and internally assimilate contaminants, thus providing link for food chain transfer of potentially toxic substance from sediments to organism in higher trophic levels. So these characteristics make hexagenous species and other burrowing mayfly useful for assessing ecosystem contamination. So that is why we decided to sample for mayflies. So how did we sample for mayflies? So for this, we use suction rays. So this happened at least week or two after the polar grab. So from the polar grab sampling, we picked the 5 most abundant sites per reach for mayflies. And among those 5 sites, 3 sites were selected to represent the largest geographic distribution for reach for tissue analysis. Um, so to give you an idea of how does this work, the dredging. So here's our boat with all the suction dredge equipment ready to go out. So I have a small video that will show you how the suction dredging is done. So once we get to our site, we start basically sucking the whole bottom. So once you see this water turning muddy, so that means it started sucking the bottom. So there you go. So it's kind of sucking the, dredging the bottom. So it is sucking everything, sediments, everything living down there. But we are only interested in mayfly. We did this because we needed certain gram of mayflies, and this was not possible just to get from Ponar, so we had to use suction rays. So once we get all these sample, we brought these mayfly back into the lab, and we rinse them with DI water to get rid of sediments or any kind of detritus, so that doesn't hamper with the actual weight of the mayfly. So then the samples were weighed and recorded, and they were preserved in, actually not preserved, they were stored in labeled glass jar, and they were kept in the freezer. And then later they were sent to Excess Lab in Canada for tissue contaminant analysis. We do not have results for contaminants yet, but we again plan to do this in 2024. So later I can show the results if I do this again. So let's go to sampling method 3. So these were the passive gears I was talking about earlier. So this was not done in the past. So this is new addition to our macroinvertebrate component in Mississippi River and Illinois River. So this is basically rock bag and Hester-Dendy. So rock bag is the this simple mesh bag with a 500 micron mesh at the bottom of this bag. So this bag was filled with some of the river rocks. They were clean, and then we put them in the bag, and the bag we just tied up the bag with the zip ties. And then Hester Dendy, these were cardboard plates, which are stacked together, but there is a space in between, different spaces made with this spacer. So these are basically ready-made house for macroinvertebrate. We build the house for them, and we want them to come and stay there, like a bug hotel. You know, it's a hotel for bugs. So, so these are suitable for larger rivers with various depth. And the reason we chose to use this was to evaluate main channel macroinvertebrate colonizer communities, which are largely understudied across LTRM river reaches. So here are my wonderful technicians, again, helping me prepare all these samplers. So basically, we are putting all these Hester dandies tied up with zip ties on cinder blocks and later attach rock bags on the cinder block as well. So we are kind of studying like a peer test, like we are later when we identify all the bugs, we will be able to say which one is best to capture bugs, either Hester dandy or rock bags, or both are equally same. So these are kind of like a pair test here. So we even put tags on the rock bags to make sure we know where they are going, and we kind of fear we might lose the tag. So my technician, they came up with the idea to pin the cinder block with the tag numbers, and they look like this, the picture on the right, when they were ready to deploy. So we deployed this during June of 2023 after we were done with our ponar sampling and suction trays. So we went out to our sites. So we have 25 sites per reach. So we went out there and deployed them there and recorded all the information in the Jeda app. So since this is a passive gear, we leave them in the water for 6 weeks. So after 6 weeks, we go back to retrieve them. And here Abby is retrieving one of our sampler in Lagrange's pool. So this is how it looks when we take it out from the river. And I just put it on the boat to take a quick picture. But as soon as we put it up, we do not have time. We process it immediately, cut down all the zip ties, and then put them in their respective buckets. And sometime, people were really curious what was in the water. So they pulled out our sampler and there was nothing to see. So they just left some of our sampler on the bank. So, we had some loss there. But mostly we were able to retrieve most of our samplers from all of our reaches. So once we bring that back into the station, we start cleaning them. So here you see Hester dandy heavily colonized with zebra mussels. And we break apart all of these plates and we scrape and we clean. So we try to get all the bugs out from these Hester dandy and rock bags, and we rinse them, clean them, and then we put them in a sample container and then we'll identify later in the lab. So that was the all the sampling method and everything. I just wanted to give you a quick preliminary data for mayfly count from our ponar sampling. So let me orient you the graph here. So in the x-axis, I have year, and in y-axis, I have number of mayflies, average number of mayflies. And this blue horizontal line represents the historic mean of mayflies, and this blue triangle here represents the recent mean of mayfly. So if you look at the recent mayfly for Lagrange's backwater, it is higher than the historic mean. But if you look at the main channel, it is lower than the historic mean. And then if you look for the pool 4, which is up in Minnesota, the historic mean is higher than the recent mean. So both for backwater and impounded region. And if you look at the pool 8, still the same. Our recent mean of mayfly is lower than the historic mean. And if you look at the pool 13, same story. Our recent mean of mayfly is lower than our historic mean. And if you look at pool 26, same story. Our recent mean for mayflies are lower than our historic mean. And then with the open river, if you look at the main channel, looks like the recent mean is higher, but it's not, it just looks that way. But still, these are preliminary. We need to do actual proper statistical analysis here, and then we'll be able to say what's going on. And then we need to process other bugs as well to tell the whole story of macroinvertebrate. So what next? So we are processing all the samples currently. We have thousands of samples from all the station, including Ponar sample, samples from Hester Dendy, sample from Rockback. So we are processing all these samples in the lab right now. And after that is done, we will be doing data recording and analyzing and developing IBI score. And at the same time, we are getting ready for our field season 2024, which is coming up in April. So we'll be doing same thing again, Ponar sampling, suction rays for mayfly, and Hester Dendy and rockbacks. So that is all I have. Thank you.
All right, thank you. That was really great. I'm just really interested in to see all the different monitoring methods that you guys do. If anybody has any questions at this point, you can either put them in the chat and I will read them, or you can ask them aloud. Okay, I'll start with a question.
Sure.
Yeah. Oh, my cats are fighting. I hope you guys can't hear that. Oh, never mind. Danielle will start with a question. When you do the suction method, do you only collect the burrowing mayflies and do the others get released?
Yes, we only get the borrowing mayflies and we dump everything back into the river. Yes.
So, my question is, when you're doing any, and this could be different for the different methods, but when you're doing all of these samples, when you're looking at the bugs under the microscope, are the samples already clean, or do you have to do all of your like sorting from sediment under the microscope?
So remember when I said when we get all the samples from all the station, so they are in formalin. So while we were transferring from formalin to ethanol, we rinse them again and try to get rid of most of the vegetation and like the sediments. But even if the samples are not great, we even wash them or put them in a big tray in the lab and then clean it. Yeah.
Okay.
But mostly clean sample, yes.
Yeah. That makes a difference when you have so many bugs to look at.
Yes. Oh, yes.
Okay, Abby asked, how does this project compare to work you've done in the past? Is there any project of this size going on elsewhere in the country?
Well, for me, this was the biggest step after my previous job. I'm sure there are other projects going on in other part of the states. I can't remember anything right now, but there are other stuff in Smithsonian they are doing in that part of the state. So yes, there are, but yeah, but this is the big one for me.
Yeah. Okay, John asked, will the results of your research lead to management recommendations?
Yes, so that's the main point. So this is the part of Upper Mississippi River Restoration Program. So once we have all these results, we send it to higher up, and they make other management decision. Yes.
Okay, and then Ed asked, could you go over the rock basket technique again?
Okay, sure. So this is a rock bag. So I followed the protocol from Fish and Wildlife. Fish and Wildlife. My coworker used to work there before, so he suggested me this bag with a 500 micron mesh at the bottom. So if there is bug inside here while we are pulling them up, they do not get loose from the bag. So we fill this bag with river rock. So I set a protocol. So we would not put, so we basically measure rocks up to like 2,000 grams. So that always end up being 15 or 16 rocks of anywhere from 1 inch to 3-inch long. So we pre-fill this bag with those rocks, just tie it up and then attach it to cinder block. So yeah. Do you want me to go over Hester Dandy also, or just the rock bag?
He only asked about the rock bag, so I think that's good.
Yeah, so it's, you know, like it's very simple compared to Hester Dandy.
So I'm wondering about with these passive samplers, how do you find them again? I mean, we put things out sometimes in small streams, and I can't imagine trying to find something like this in something as big as the Mississippi or the Illinois when we have trouble finding them again in small streams sometimes.
So some of these field station, they have really precise GPS unit, and I think it was Pool Station, Pool 8. They were able to retrieve all of theirs. But at my station, my co-worker, Levi and Chris, they know the river so well, even without the GPS, they can just take me to where they are deployed. So I'm just lucky to have these co-workers.
That's actually pretty impressive to know a water
but
body
you
that
know,
well.
but there are GPS point also, and then you always make a note of, you know, like what was on the site, you know, if there was a bars or, you know, something, you always make some comments, and then you take extra GPS points also. But Levi and Chris are so great with the rivers, so yeah.
Yeah. So to kind of follow up on that, how deep do you set the Hester Dendy and rock basket samplers?
So usually we try to do in a photic zone, you know, so we can be visible, but if you know these rivers, they are not that visible. So we set it anywhere between 1.5 meter to 3 meter, because we need to also consider about the fact that in summer the water level may go down. So nothing below. Yeah, so it was always between 1.5 meter to 3 meter.
All right, does anybody else have any questions? Thank you again, Manisha, for presenting with us. It was a great presentation. And before everybody leaves tonight, I just want to mention that our next Winter Speaker Series event will be on Wednesday, February 21st at 7 p.m. Jinyu Wang from the University of Illinois will be presenting on some critical zone research that is going on in the Sangamon River. Also, the dates and locations for our spring training workshops will be announced next week. So if you are interested in getting out into a stream and collecting your own macroinvertebrate data, you can attend one of our workshops to become a RiverWatch community scientist. You can register for these and other future activities on our website and or on our Facebook page. All right, thank you everyone for coming.